Okay, so today's lesson is on geometry. So we're moving into a new unit. Geometry is probably my favorite unit. I really like geometry. That was the first math class I ever taught was geometry. So I really like it. Similar figures uses what you've learned already with ratios and proportions. So this is a really good review of that as well. So our objective is just one. We're using proportions to find missing lengths in similar figures. I want to look at this problem with you. We're going to come back to this problem after we learn a little bit, but this kind of shows you where we're headed and what kinds of problems we're going to be able to solve. A 6-foot tall person, here's our person, standing near a flagpole casts a shadow 4.5 feet long. The flagpole casts a shadow 15 feet long. What is the height of the flagpole? So if we wanted to measure the height of a flagpole, that would be pretty hard to do because we can't reach to the top of the flagpole to measure it. We'd have to get in one of those cherry picker things or something, or get a big ladder. We'd have to climb up. However, it's really easy to measure a shadow because a shadow lies flat along the ground. So we can use the concept of, we can make a triangle out of these two figures. These triangles are similar because they're like one is a shrunken version of the other. This small triangle is the same triangle as the big one, except it's shrunk. So all of its angles inside the triangle are the same, and then the sides are proportional. So what I mean by that is this bottom side, why is that not right? There we go. This bottom of the triangle is proportional to the bottom of this triangle. Those sides, we say that they correspond. They're in the same position on both triangles. If I were to look at the flagpole itself, that corresponds with the height of the person. If I were to look at this diagonal line, which isn't drawing, there we go. That corresponds with the diagonal line on that triangle, which by the way is called a hypotenuse. You will not need to know that for this class, but you'll learn that next year. Okay, let's take a look at some examples with just triangles. So for example 1, we have two triangles that are similar. They look like the same triangle. One's a shrunken version of the other. If I look at the side with a 12, which side on the smaller triangle would correspond to that side? Olivia? 3. The 3. So this side corresponds with that side. So I can say, I can set up a ratio of 12 to 3, starting with the first triangle, using the second triangle then. Okay, let's look at the side with the 20. What side in the smaller triangle does that correspond with? Jace.
Which number are we on?
Which side on this triangle corresponds with the blue line on this triangle?
X.
X, good. So as the second part of my proportion, I can say 20 to X. These ratios are the same because the triangles are similar. So I can use that to find out what X is. So solving this proportion, Austin, can you remind us how we solve a proportion? What do we do?
12
Mm-hmm.
times X
Good.
and 3 times 20.
Okay, what is 3 times 20?
60.
Good. And then what do we do?
Multiply it?
No, we want to find X. This says 12 times X. What's the opposite of that?
Divide.
Divide. Do you know what 60 divided by 12 is? 12's times tables?
5, 6, 5.
5 is 5. So X is 5. So we know that this side is 5. Okay, let's set up number 2 similarly. So let's start with Brian. What side do you want to start with on the smaller triangle? You want to start with the X or the 1?
1.
Okay. What side on the big triangle corresponds with the 1 on the little one? Okay, so 1 to 3.
The number.
Well, no, if we started with the first, or the first triangle was on top, first triangle still needs to be on top. So instead of 9 to x, we need to do x to 9. Always keep them in the same order, otherwise it will get mixed up. Okay, can you solve that for us?
Do 9 times 1,
Is
9.
9, and that equals,
Don't divide by 3.
divide by 3. So I'm going to actually write this out as 3x and then divide by 3. And you guys don't have to show all the steps in solving a proportion if you know how to do it. So we get x equals
This is
3.
easy.
Yeah, this is a pretty easy concept. That's why I chose to move ahead with it, even though we have a lot of people missing. Sammy? Sure. Okay, so what side do you want to start with on number 3?
X.
X, okay, what does x correspond with on this triangle?
8.
Good. So what ratio could we write?
X over 8.
Good. Okay, now what does the 4 go with?
16.
Whoops, that was supposed to be a new color. Okay, so what ratio can we write?
4 over 16.
Good. And can you solve that for us?
So you have to do x times 16, which equals 16x. And 8 times 4, which equals 32.
Good.
And if you do the ratio divided by 16, you should get 2.
Okay. So x equals 2. Excellent job. Try to volunteer to do number 4. Go ahead, Caleb. What do you want to start with?
X.
Well, let's start with this triangle. So if you want to do the x, what side on this triangle corresponds with x?
5.
The 5. Okay, so 5 and x. So what ratio can I write?
5x.
5 over x equals what?
4 over
Good. 4 over 8. Okay, can you solve the proportion for us?
4x equals
40. Good.
divided by 4.
Good. X equals
10.
10. Very good. Any questions so far? This is kind of nice coming out of what we just finished to have something like this that's a little bit easier. Okay, we're not going to continue to do all of them. I do want to look at number 7. Number 7, the triangles are tilted differently. So numbers 5 and 6, you can see the triangles they're in the same orientation. Number 7 is oriented differently. Now, those of you who are watching the video have an advantage over those of you who are in class, because in class you are looking up at my screen. And on my screen, because of the way my computer projects to the screen, it compresses the picture a little bit. So if you look at the picture on your notes and you look at my picture here, it looks different. So don't look at the screen right now. Look at your notes, okay? Because up here it's distorted. The sides that should go together don't go together. So I'm looking at the side on the first triangle that has a base of 9. If I were to flip the second triangle around, and again, look at your paper, not on the screen, which side on the triangle on your paper would correspond with the side with the 9? Brian?
X.
X? Well, let's see here. No, X looks like it's a longer side. And 9 is a shorter side, the 99. Good. So if we look at the first triangle, we have a short side. It's an isosceles triangle, which means it has 2 other long sides that look like they're about the same. So if we look at our second triangle, if we were to sort of set that on its side, 99 would correspond with 9. Okay, and that's really hard to see up here, but if you draw it on your paper, you should be able to see it that way. And then, whoops, didn't switch colors for me again. And then the 10 is going to go with X. So sometimes you have to do that. You have to rotate the shape so that it's in the same orientation as the first shape. Okay, let's set up a proportion for this. Thomas, what proportion would I set up?
You would do 9/99, right?
Yep.
And then you do 10/x.
Good. Okay, what do we
do?
do?
99 times 10.
Okay, which is? You shouldn't need your calculator, you can just add a 0.
Oh yeah. That'd be that 990.
There you go.
Divide that by 9, and then you get 110.
Good. Okay, now I'm going to have you go back to our first page, to our first slide. And I want to take a look at this problem because now we can solve this. So we have two similar triangles. The problem's all set up for us, so we can actually solve this. Ben, can you tell us what proportion we would set up for this?
4.5 over 15.
Well, since we've been starting with the first triangle on top, let's keep it consistent. You could do it the other way, but to be consistent, let's do 15 over 4.5. So we'll always just put the first triangle over the second. Okay, and then what would our second ratio be?
X over 6.
Good. X over 6. Okay, want to solve that for us? Ben, you can just tell us
20
steps. So the answer is 20. Can you tell us what you did to get 20?
15 times 6.
Okay, and what is 15 times 6?
90.
90. Okay, so we have 90 equals 4.5x. Then when you divide by 4.5, is that when you got 20?
Yeah.
Okay, good. Because 45 goes into 90 twice, so 4.5 would go into 20. Okay, good job. I want to see how well you guys understand this, so I would like you to go to the second slide to number 5. I want you to solve for x. When you find x, you're going to enter your answer on Socrative. So you're doing number 5, and you're going to enter your answer on Socrative. One. Okay, so our proportion is 6 over 24 equals 9 over x. And then what did you get as an answer, Caleb?
X equals 36.
Good. X equals 36 is the correct answer. Some people had an answer of 6. Some people had an answer of 2.5. My guess is that you maybe set up your proportion incorrectly on that.
How do you know if it's 6 or 9 that goes on the top or bottom?
Austin, let's try that again. How do you ask a question? Austin, go ahead with your question.
How do you know if it's 6 or 9 that goes on top? Wait, how do you know if it, like, which one it goes with the other number?
Okay, watch carefully. The 6 corresponds with the 24, right? So we're starting with the first triangle. We're putting that number on top. The second triangle is going on the bottom, corresponding sides.
Oh, that makes
Okay.
sense.
Got
It's
it?
so easy whenever you look at it like that.
Okay, next, I would like you to try, we're going to skip around a little bit. We're going to go to this slide, the you try. Okay, so you might want to draw a picture of this. In fact, I recommend you do that. It's like the flagpole picture on the first page. Solve it, and again, you're going to enter your answer into Socrative.